Welcome to Brain Vision.
So in the first part of this podcast, we're going to be using the TXY diagrams, which is temperature versus mole fraction in liquid and vapor pressure phase, for a component that is often an easier way to calculate the bullet points, the dew points, and the relative compositions. So we need to look at the TXY diagram for benzene in the first part here. So we find that the first drop of vapor condenses at 104 degrees C. And then we move horizontally from this point to the liquid curve and determine the mole fraction of benzene in the liquid is 0.14, and that the mole fraction of toluene in liquid is 0.86. So in the second part here we have the mole fraction of benzene in the liquid and the vapor at 100 degrees. So we can use a basis of 1.0 mole of original vapor, and then we can write equations for the mole balance of benzene. So what we have is YB0 multiplied by NT is equal to YB multiplied by NV add XB multiplied by NL. So we have 0.30 multiplied by 1.0 mole is equal to 0.46 NV add 0.24 NL. So we'll jump onto a fresh page here. So NV and L are numbers of moles of vapor liquid, and YB0 is the mole fraction of benzene in the original vapor. So the total mole balance, we have NT is equal to NV add NL. So NT is essentially equal to 1 mole. We solve for NV and NL. So we know that NL is equal to 0.73 mole. NV is 0.27 mole. 0.27 divided by 0.73 is equal to 0.37 when we divide them by one another. So for this last part here, we need to take a look at the TXY diagram again for benzene. We move down vertically from the full vapor with a 0.3 mole fraction of benzene at 115 degrees Celsius. That's our temperature now. And a line that intersects at the liquid curve at the temperature of 98 degrees Celsius temperature. So that is the last drop of vapor that condenses at 98 degrees Celsius. So then we move horizontally from that point to the vapor curve, and we can see that the mole fraction of benzene in the vapor is 0.53.